Okay, so let us now discuss question number 48. We have discussed up to question number 47. So 48 question says a solid sphere of radius 6 centimeter is melted into a hollow cylinder of uniform thickness. If the external radius of the base of the cylinder is 5 centimeters and its height is 32 centimeters, find the uniform thickness of the cylinder. Okay, so what the question says is that there is a solid sphere of radius 6 centimeters and I melted this sphere to form a hollow cylinder. So what we can see, this is a question of conversion of solids. Now if a solid sphere is melted to form a hollow cylinder, it means whatever the material that solid sphere contains is used to make the hollow cylinder. Now if the cylinder is hollow, then we can see the shape of the cylinder. Shape of the cylinder will be something like this. Like this. Okay, this is the hollow cylinder. The material that is taken from the sphere is used to make the walls of this cylinder. Please remember, it's a hollow cylinder. So what will happen, this portion, the inside portion, there is nothing. Okay, the cylinder is not, the material of the sphere is not used to make the internal portion of the cylinder, it's only used to make the walls of the cylinder. Okay, so it's a cylinder of a well defined thickness. This cylinder has some thickness. Let us say the external radius of this cylinder is R1 and the internal radius of the cylinder is, let us say we mark it here, it is R2. Okay, so R1 is the external radius, R2 is the internal radius. So the thickness of this cylinder, if I talk about thickness, then thickness of this cylinder is defined as external radius minus internal radius, that is this length. Okay, this length represents the thickness of this cylinder. Now if I want to calculate the thickness of this cylinder, it means somehow I need to determine the radius, the external and internal radii of this cylinder. Okay. Now if the external radius of the base of cylinder is 5 centimeter, now in the question it is given that the external radius of base is 5 centimeter. Okay, external radius, that is R1, is given as 5 centimeters and the height of cylinder, it is 32 centimeters. So this is the height of cylinder, this is given as 32 centimeters. This is 32 centimeters, that is the height of cylinder. And now the solid sphere, if I make a solid sphere, the solid sphere is something like this, the radius of the sphere is 6 centimeters. Now what is the quantity, what is the amount of material that this solid sphere contain? I will say the amount of material present in solid sphere is equals to 4 upon 3 pi r cube, that is the volume of this cylinder. Okay, this is the volume of this, volume of the sphere. So it will become 4 upon 3 pi into 6 to the power 3 centimeter cube. Okay, this will be the volume of material. Now this material, this much amount of material is used to make the walls of this cylinder. Now what is the volume of the walls of this cylinder? Since it's a hollow cylinder, so the volume of hollow cylinder if we talk about the volume of hollow cylinder, it will be equal to volume of outer cylinder minus volume of inner cylinder. So outer cylinder is pi r1 square h minus pi r2 square h. This is the volume of outer cylinder. Now since the material that was contained inside the sphere is completely used to make this hollow cylinder, so what I can say, that in the conversion of solids, the volume, the amount of material will remain same. So what I will do, I will equate these two values. So I will get pi r1 square h minus pi r2 square h is equals to 4 upon 3 pi 6 to the power 3. So from this I can cancel pi, and the value of r1 is 5, square of 5 into h is 32 minus r2 square into h is 32 is equals to 4 upon 3 into 6 into 6 into 6. This is what we can get. Now I can take 32 as common, it will become 5 square minus r2 square is equals to 4 upon 3 into 6 into 6 into 6 upon 32. Okay, this will be 32. Now this is 3 ones are 3 twos are, then 2 and 4, 2 fours are, this is 2 into 4 is 8 and 8 fours are 32. So this 4 is 1, then this is 3 and this is 3. So I will get this as 9. Okay, this will be 9. So from here I can write that r2 square is basically 25 minus 9, that is 16, and from this r2 is equals to 4 centimeter. So we get the value of r2, that is the internal radius, as 4 centimeters, and the thickness is defined as r1 minus r2. r1 is 5 centimeters minus r2 is 4 centimeters, this will give you 1 centimeter. So 1 centimeter is the thickness of this cylinder. Okay, so this completes question number 48, an easy question. Okay, note this, then we will continue. Okay, so let us now solve question number 49. A factory manufactures 1,20,000 pencils daily. The pencils are cylindrical in shape, each of the length 25 centimeters and circumference of base as 1.5 centimeters. Determine the cost of coloring the curved surfaces of the pencils manufactured in one day at rupees 0.05 per decimeter square. So what the question says is, no, it's decameter square. Okay. What the question says is that there is a factory which manufactures 1,20,000 pencils. Now the pencils are cylindrical in shape. So if I draw a pencil, so how the pencil looks like? It simply looks like a cylinder, like this. You have seen the normal pencil. It is in the shape of cylinder. Okay, like this. This is a pencil. Okay. So for this pencil, the length of each pencil is given as 25 centimeters. So the length of this pencil, this is 25 centimeters, and the circumference of base. Circumference means this boundary of its base. This boundary, circumference C, which is 2 pi r, where let us say r is the radius, this is given as 1.5. Okay, circumference is given as 1.5, and there are 1,20,000 pencils daily manufactured. So total pencils manufactured daily is equals to 1,20,000, is equals to 1,20,000. Okay, Determine the cost of coloring the curved surfaces of the pencils manufactured in one day at the cost of rupees 0.05 per decameter square. So I can say that what is the cost of coloring? It is rupees 0.05 means 5 paise per dm square. Okay. Now in the question, this circumference and this height, this length and circumference are given in centimeters, while this is in decameters. So what I will do, I will convert this unit. So I know that 1 dm square is equals to 100 centimeter square. Now how I obtained this result? It's because 1 decameter is equals to 10 centimeters. Okay, this is deca means 10. So 1 decameter is equals to, 1 decimeter, it's equals to 10 centimeters. Okay, so 1 decimeter is equals to 10 centimeter. If I square both the sides, I will get this result. So the cost of coloring is given as, cost of coloring is 0.05 per decimeter square. So cost of coloring is rupees 0.05 per decimeter square. So 0.05 per decimeter square is the cost at which I can color. Okay, I can color the pencils. But it says that 1 decimeter square is 100 centimeter square. So if I want to convert it into centimeter, in place of this decimeter, I can write that cost of coloring is rupees 0.05 per 100 centimeter square. That means if I want to color 100 centimeter square area, I need 0.05 rupees. Okay, so this is the cost of coloring. Now let us determine the curved surface area on which I can color. Okay, so the area on which I want to color is the curved surface area of each pencil. If I calculate the curved surface area of each pencil, you can see this is the curved surface area. Okay, this is the curved surface area. So curved surface area of each pencil will be equals to 2 pi r into h, where 2 pi r is the circumference. So this is 1.5 into height is 25 and this is centimeter square. This is the curved surface area of each pencil. Now what is the total area I need to paint? So total area or total curved surface area to be painted is equals to 1,20,000 into curved surface area of each pencil is 1.5 into 25. Okay, 1.5 into 25. So this is the total curved surface area in centimeter square. This much area I need to paint. Now this is the area, but what is the cost of painting this area? So the total cost required, total amount required to paint this area, to paint all the pencils, we know that for 100 centimeter square, to paint 100 centimeter square, I need rupees 0.05, and for 1 centimeter square, I need rupees 0.05 upon 100. Okay, this much is the amount required to paint 1 centimeter square, but I have this much area. So I need to paint this area, and how can I paint this? I need how much rupees? So total amount required, total amount will be equals to 0.05 upon 100 into 1,20,000 into 1.5 into 25. So this is the total amount required. When you calculate it, it comes out to be 2250 rupees. It comes out to be rupees 2250. Okay. So this is the 49th question. Okay, I already cancelled it. So you note this, then we will continue. Okay, let's solve the 50th question. It says the height of a cone is 30 centimeters. A frustum is cut off from this cone by a plane parallel to its base. If the volume of the frustum is 19 upon 27 of the volume of the cone, okay, that is the volume of the frustum is equals to 19 upon 27 of the volume of cone. Then find the height of the frustum. You need to find the height of the frustum if the volume of frustum is 19 upon 27 of that of cone. So let's draw the diagram. Question number 50. There is a cone like this, and the height of the cone is given as 30 centimeters. What I did is I made a frustum from this cone. I took out a frustum from this cone such that the volume of this frustum is 19 by 27 times the volume of cone. If I assume the base of the radius of this cone is r, then what is the volume of this cone? Let volume of cone is V, this is equals to 1 upon 3 pi r square into h. H means 30, that is height. So this will give you 10 pi r square centimeter cube. This is the volume of cone. Now what is the volume of frustum? If I ask you what is the volume of frustum, then volume of frustum is, it's 19 by 27 times volume of cone. Okay, 19 by 27, yes, it's 19 by 27. Now if I ask you that the total volume is V and this volume is 19 by 27, then what is the volume of this smaller cone? इस छोटे कोन का वॉल्यूम क्या होगा? So volume of smaller cone is equals to V, that is the volume of frustum, volume of cone minus 19 upon 27 volume of frustum. So this will give you 27V minus 19V upon 27. So what is 27 minus 19? It will give you 8. So this will become 8 upon 27V centimeter cube. So let us say the volume of smaller cone is V1. V1 is the volume of smaller cone. This is equals to what? It is 8 upon 27 into V is 10 pi r square. 10 pi r cube. I have made it square, This is cube because this is, This is square, It's 1/3 pi r square h. So I am making a mistake. It's not a sphere, it's a cone. So V1 is 8 upon 27, 10 pi r square centimeter cube. This is the volume of the smaller cone that I have, the smaller cone. Now this is the volume of smaller cone in terms of the larger cone, because I can see 10 pi r. R is basically the radius of larger cone. If I ask you what is the radius of this smaller cone, this radius, let us say this is R1, and what is the height of this smaller cone? Let us say the height of smaller cone is H1. Let us say height of smaller cone is H1. Now I can see this is, let us say, point A, this is, let us say, point B, this is a straight line, this is, let us say, point O, this is D, let us say this is C and this is D. So I can see that in triangle ABC and triangle AOD, If you consider the two triangles, one is ABC and another is AOD, in both these triangles you can see this angle is common for both the triangles. Similarly, this angle is 90 degree and this angle is also 90 degree. So I will say triangle ABC is similar to triangle AOD by angle-angle corollary. In the similarity of triangles, we have studied about this angle-angle corollary. So ABC and AOD are similar, and if ABC and AOD are similar, I can say that H1 upon H is equals to R1 upon R. That is, the height of this triangle upon the height of complete triangle, this bigger triangle, is equals to the radius of smaller triangle or the base of smaller triangle upon the base of larger triangle. So from here what I can see is that radius is equals to this R, or let us say this R1. R1 is equals to H1R upon H. Now we know the value of H. What is H? H is the height of larger cone, that is equal to 30 centimeters. So from here I can get R1 is equals to R H1 upon 30. But we do not know the value of R, that is the radius. So what I can say is, if I get the value of R1, if I ask you what is the volume of smaller cone, the volume of smaller cone, that is by formula I have the volume of smaller cone as 1 upon 3 pi R1 square H1, okay. This is 1 upon 3 pi, R1 is RH1 upon 30 whole square into H1, okay. This is the formula for volume of smaller cone in terms of its radius and in terms of its height. Now I can see this expression also represents the volume of smaller cone, this expression also represents the volume of smaller cone. So I can equate both the expressions. What I will get? It will give you 1 upon 3 pi into R square into H1 square upon 30 into 30 is equals to, this is 8 upon 27 into 10 into pi into, this is R square. So here also I will substitute R square, okay, not R2, it is R square. So I can cancel R square and R square, I can cancel pi and pi, I can cancel anything else to be cancelled. No, yes, this will cancel, this 10, this is also 10 and this is 7, okay. So I will get H1 square is equals to 8 into 10 into 10 into 10. Is there anything left? No. So from here I can get the value of H1. Am I missing anything? Yeah, one more H here. Yes, it is 1/3. This is only R1 and into H1 also. So this is H1 cube. This will become H1 cube. So the value of H1 will become 2 into, this will give you 10. So that is 20 centimeters. So 20 centimeter is what? It is the height of smaller cone. And if I ask you what is the height of frustum, the height of frustum will become H minus H1, that is 30 minus 20, that is 10 centimeter, okay. This is what the height of frustum is, okay. So this completes question number 50, okay. So you can note this.